But before fragmentation, we need to prepare our geometry a little bit better for fragments because it doesn't have a thickness, so it's just simple geometry. As I said, it's not prepared for any kind of dynamic, just for rendering. So what we should do, I turn off the UV and warp here, I turn on my attribute delete, just make a few tests. So what we need to do, objects. You can see here some points in this area. We select the points, not you, selecting some points here. You can see that, oh come on, just primitives or points. They don't create any kind of geometry. Actually, it's just geometry, but it's very, very small. And when we begin to create some kind of subtraction, or when we begin to work with extrusion, I want to create a thickness for geometry, very small elements can cause some problems. All right. So what we should do, there is some problems with, let me turn off this guy. Don't need a compositing view. Let's leave it dope shit, animation editor. So let's create another scene. All right, cool. So where's my nodes? Okay, here's my ship. So I need to make sure that there is no any problematic objects. How we can deal with this? Well, the first thing we can do is make a simple clean. So again, if you look closely to this guy and add a clean node, you can see I try to create or try to select the big objects, and all small objects I transfer to the other group. But when we convert geometry, it can be that, again, we can have some small objects in our model. So let's find out, do we have the small objects or not? So the first thing I want to do here is create a connectivity to have an ability, and let's set a class for primitives. So if I use the exploded view, now I can see the objects separately. And if you go to geometry spreadsheet, you can see that we have 1,550 different objects here by the class. All right, and now we can take each of those objects and add some kind of poly extrude node or something to add a thickness for the objects. But before I do this, let's measure those primitives. So if I add the measure node, let's enable that. So the measure node or measure sub is a very useful tool, because in this case, what I can do is just create the area. I can measure the area of each primitive. So we can see that the element type is primitive and the measure is area. If you go to geometry spreadsheet, you can see that each primitive now have the area attribute. But I don't want to measure just each primitive. I want to measure each object. Okay, so by connectivity now, we can see that we have a separate elements. So now I want to measure area of each element. So to do this, go to measure utility and choose per piece. And by default, you can see that the piece attribute is class, and it's good because we have a class attribute now. And if you go back to geometry spreadsheet, now you can see that we have an area and we have a class. So you can see that now we measure all elements. So if we have a class 2, let's say, you can see that we have a area 1647.08. So it's like a size or area of each element. It's very good because now using the blast node, we can say that, okay, if this area is smaller, let's type area is less than, let's say 1. Okay, let's delete non-selected, and now we can see that there is a lot of small objects which have the area less than 1. If we come closer here, you can see that, well, maybe 1 is too much, but anyway, yes, 1 is good. Maybe 2. I don't want to remove big fragments, so let me open this. And yeah, maybe 2 should be fine. So now we remove all elements which have the size bigger than 2. All right, but I want to blast them. I don't want to remove them. I want just to send those small fragments maybe to the other group, okay, because this group where we put small elements. So I can copy this guy, and except of the blast node, I can use the split node. So we can use 2 blast nodes or 1 split node, because 1 split node has the 2 outputs. If I paste here area less than 2, now you can see from we visualize always the first output. If you want to see what is going on in the second output, we can connect the null object and enable this. So actually I want to switch between those, so I enable delete and invert selection. So now from my first input, if I enable split, I have my alt geometry but without those small objects, and from the another output I have a small object. So you can call it out small, something like that. And maybe I can merge, let's say the merge node, and I can connect those guys with the other. Okay, so with the other group, let's put this merge over here. So to avoid any problems, because in this merge node I take our geometry with the small parts, okay? So except of this connection now, if I want to have all groups, I can connect this geometry and reconnect here. All right, so now I have a full geometry over there. And correct, because if I connect this original and then split small objects, connect them with other, and then again merge them here, that can cause problems. All right, so now here we have a small objects, and again we can recache this thing. I can do this later, because for now I want to make sure that I have a proper geometry for adding the extrusion or polyextrude node. So that's can call big elements. All right, so now let's work with them. We already have a class attribute here, so I can go to the for each loop using the name primitive, because we have a name for our primitive, and this name is class. Now I connect this loop for our geometry. Oh, not you. Go to scene view. Here's my geometry. Let's select my for each begin, and let's look at my first geometry. You can see that it's very small geometry. Okay, so it's just piece 1 of 215 pieces. All right. And in fact, if you look at this geometry, it doesn't have a thickness, right? So I need to add the thickness, because if I want to fragment, add a fragmentation, I need to have it. So what we can do, we can add the polyextrude node. So the simplest way to add a thickness is using the polyextrude. Make it enable, and there is a few options. We can use distance, insert, twist to divisions. Yes, I want to increase the distance. So basically we take all primitives and create some kind of a distance between those primitives, like here. So it's like minus 0.03, I guess it should be fine, maybe 0.2. If we set the plus, then we extrude it out. If we use the negative value, we extrude it in. All right. So, but if we look at our geometry for all of our fragments, look over here, if we apply polyextrude, come on. You can see some problems here, big problems. So the first thing we need to deal with is, in fact, create a remesh, because geometry can have some problems. You go to normals, it's looking like all's fine for this piece of geometry, and it's looking pretty good for our all other objects. But if you look at the polyextrude, how this works, for now you can see that we have some problems. But we have the primitive and edge normal extrusion model. If you want to, it's a little bit can be better if we use the point normal. If you select this, then we're gonna have a more proper result, more correct. There's no like an extrusion far away from the ship. Let's turn off our normals again. Now you can see that we have, well, we have a lot of thickness for our geometry. Let's switch it here. We can't see it because there is no output back. Yeah. Come on. And now I hope we can see it. Sometimes it's hard to see, but yes, we have it. We have a thickness. We can see that we have now normals like our back part. So we need to take a reverse. We need to add a reverse for reverse U. And it should help. Now it's looking fine. But what else I can do here? I can set a remesh, because again, the mesh is not created for a fragmentation. So I add a remesh node, but before I connect this remesh to our for each loop, I want to make some changes. I don't want to have a smoothing, any kind of smoothing here. So make it 0. And choose use input points only. Now when I connect this remesh, you can see a difference between those objects. So it's now a little bit different, but let's decrease the target size, because I don't want to have this, bad corners, maybe even smaller. Uniform, now that's fine. Okay, so you can see a difference between original geometry and this. Okay, maybe 4, I don't know, yeah, like this. Then polyextrude, then reverse normals. If you look at the old geometry, you can see the final result. Okay, so the geometry is still the same. You can see a nice texture, but now we have a thickness. We have normals inside and outside. So before we, let's just compare geometry this and this. So you can see there's no difference except of the thickness. All right, let me check this smooth, and with this smooth, have some problems, I guess. Yeah. With the smooth wire shaded mode, we have some problems. So let's go and set the facet node. And a facet node can help us to create the proper normals, because that what you look for now is incorrect normals, I guess. So post-compute normals, that's the one thing I want to enable here. And another one is cusp polygons. You can see that without the cusp, our geometry is like, I don't know, like a bulge on the surface. You can see those reflections. It's not correct. So cusp polygons, I think I can keep cusp angle like 220, should be fine. And after that, we're gonna have the proper geometry and we're gonna have the proper normals. You always should look at your geometry while you work with this, while creating fragments, while you change something with the geometry, because sometimes somewhere in the beginning stage you can miss something, you can do something incorrect, and then when you render out your like a final cache with your fragmentation, with your dynamic, those explosions and everything, you can see that something wrong with my geometry. I don't know why, but it's looking weird on rendering. And this can this can happen because somewhere at the beginning you can just make an incorrect remeshing or something like that. But before the facet node, I guess that I will use another one, node fuse. Mostly I'm not using this node in older versions because when I use a Voronoi fracture, that is a fuse by default. But now there is no such node, and in many cases I use the fuse node separately when I work with geometry. I don't know, do I need to do this? In fact, let's go and look how many points do I have. So 144, and if I turn off this node, so I can simply look at the functionality. Do we have a different, do we have a different points number? Because if fuse works, if it's connecting 2 points, which is very close one to another, and you can see that yes, without fuse we have, again I forget 144, but I don't remember the exact number of thousand. So 452 144. 452 144. And now let's look at this. 453 157. So you can see that our points amount is changing. So we remove some points which are very closer one to another, and that's fine. Okay, so the face of the fuse, and this geometry now we can use for fragmentation. So set a null object, and let's call this out geo. And as we can do this is set a name using the assemble node. Just, I don't need to connect inside edges, just add a name. You can call this piece slash and have a name for this piece 0, and so on and so forth. So we can remove, if you want to, we can remove the class attribute if you will use just a name. All right, so that's what we have. I prefer to use like a black node here and the red one here to make something more visually represented, because I can see I remove something. If I have a red, if I have a black, it's like the end of something. So we did it. We create a thickness for geometry, and we can use this geometry now for fragmentation. Maybe there is some problems can happen when we create the fragments, but we will look at this a little bit later. So now let's back here, and I want to add the last geometry element for our ship is the guns. So how we can do this, again, like we did with all this geometry. So maybe I will copy this holding Alt key, or just make a copy. Okay, here you go. And let's work with the guns. Let's select you, and one by one, I guess, gun. So that's gonna be gun 1. Green, what does it mean? Gun 1. I will convert this. I'm not sure that I want to warp this guy. Apply the material, the basic material. Okay, let's use this. So this is my gun. Let me turn off and warp. Yeah, I get that I can remove this. All right, and there's a lot of different guns, so I can simply merge multiple files here. So gun 2, connect. Okay, there is a bigger one. So now let's do all this stuff again. Gun 3, gun 4. I guess there is 8 guns different. I don't remember exactly. 5. 6. Let me look. Yeah, 8. And 7. And 8. Now let's connect them together in one merge node. It takes some time because there's a lot of, and here you go. Here are my smaller and bigger guns, which is good. So I'm gonna do the same with those. I can connect, I use the connectivity. Where is my connectivity? No, not you. For those who doesn't know that if you select the node and using the tab create like another node, and when we press enter and hold the shift button, it would automatically connect to the selected node for now. All right, so the connectivity as in always for primitive. And again, I can use the measure node and the measure and split, I guess, or the blast or split, just to find out how many small elements I have here. So I'll set a null object. Look at here. And send them into the other, I guess, if we have. And yeah, there's a lot of small elements. You can see here those gun is created by the small elements. And yeah. And that's what we have for now. Cool. Yeah. So this is our small stuff connected here. And all other elements we will use. Let's just make sure that somehow those guns are not properly converted. There is something wrong with the normals for those. I don't know what's happened with those guys. After conversion, let me select them. Where are they? Just want to find where are those guns. No, not you. Anyway, we can just manually select them. So if you go here, using the primitives and using the group, I guess. No, the shop material, no. And have an attributes, okay. I can simply turn this off, simply select, or not, I want to find them. Here we go. So if we convert, okay. We will back soon. And we're back again here. So let's make a proper interface. So I save version 02 because each time when Houdini fell down, I save as a new version because that's how I can make sure that my last version should be fine. Sometimes when creating the autosave with crashing, sometimes it can just make the bad saving and this project won't open again. So I find my guns and let's do the same thing we did with the incorrect normal. So we reverse in the beginning and then I apply the normal. And let's do the cusp by the points again. And it should work fine. Now with the splitting. Should work. Okay. Where, yeah, okay, here's my guns. All right, this all works fine. So let's go ahead. And now I can use those guns just like geometry for my fragmentation, or I can use them in my dynamic. So I will not put those guns into my main geo. I just can, I don't know, can save this as a separate file cache. Let's call this guns. Guns. Let's remove the heap name. Don't need a $F. just one single frame, load from disk and save to disk. Oh, forget about this to the cache. Right. Okay, and that should be our guns out. Guns out. Cool. So now our geometry is already ready for fragmentation. And you know what? I guess that I'm gonna add my guns to the ship asset also. So save to disk. I want to look at that. It takes some time because there's a lot of elements. There's a lot of small objects and a lot of polygons and primitives. So when this thing ends, I will show you the all model with all elements on my ship. And here we go. We still some, I guess, problems with normals for the other group, for some small elements. And I guess we will remove those guys. I don't know what it is, and just I think some mistakes in model. So now our geometry is ready for fragmentation and ready for dynamic. Okay, we'll see you in the next week.